Okay, we're going to go ahead and talk about Pythagorean theorem. I have a guided worksheet for us to do a couple of example problems on. And during this portion of the lesson, we're also going to talk about simplifying radicals, writing radicals in simplest form. So I'm just going to go ahead and read along here. The Pythagorean theorem. It's a theorem we're pretty familiar with. States a squared plus b squared is equal to c squared. This will be the formula that we'll be using 100% of the time. The Pythagorean theorem is used to find the missing side of a right triangle. The hypotenuse is always c. It doesn't matter which leg is a or b. Leave your answer in radical form unless it is a real-world problem. So, as you can see here in the diagram, the longest side of the right triangle will always be c. So, when we get into this a little more in depth and more in detail, we're going to talk about how that always needs to be the longest side. So if you have a leg that's longer than the hypotenuse, that means something's gone wrong. But regardless, as it says in the paragraph above, it doesn't matter which leg is A and which one is B. So this could technically be leg B and this could be leg A. You'll get the exact same answer. They're interchangeable. But the hypotenuse is the one thing that cannot change because it's the longest side. So we're going to do two examples. First one where you find the hypotenuse, second one where you find one of the missing legs. Okay? So let's go ahead and get right into it. One thing I like to do is identify my variables, my A, my B, and my C in this case. So my leg B right here will be 15, and my leg A right here will be 22. And my hypotenuse is represented by the variable x, which is my c. So now all I need to do is plug these values, the 15, the 22, and the x, which is a variable, into the formula. So step number one, we're going to fill in the formula. So it is a squared. My a is 22, so it's going to be 22 squared plus b squared. 15 is my b. I can see that. B squared, so my 15 is b, so it'll be 15 squared is equal to c squared. Well, my c is represented by the variable x, so I'm just going to write an x right there. Okay, so that's the first thing you always want to do is fill in the formula. Next, I'm going to simplify. Okay, so two ways I can do this. I could take my calculator, and I'm not sure if you guys can see that here. I'll do it without the calculator to start. But regardless, I can go ahead and break down or evaluate what 22 squared and 15 squared is. So 22 squared is 484. So I will write 484 plus whatever 15 squared is, which is 225. Forgot to write the x squared there, is equal to x squared. Okay? So then I'm going to move the rest of step number 2 down to this third box because I'm a little tight on space. But then I'm going to add 484 and 225. And when I add 484 and 225, that gives me a total of 709 is equal to x squared. Okay? So now, move the paper up here a little bit, and now, step number 3, take the square root and simplify it again. So when we take the square root, just like all things algebra, what we do to one side, we have to do it to the other. So I'm going to take the square root of both sides, because I'm solving for x, not x squared. So I'm going to take the square root of x squared. And the square root of x squared, well, that's just x. So x is equal to, well, when I do to one side, I have to do to the other. So the square root of 709. Okay? So normally in situations like this, we would simplify the radical a little bit further, or if it's a real world problem, we would leave it as a decimal, or write it as a decimal. But since this is not a real world problem, we don't need to do that. But now, I'm going to take the square root of 709. Well, that's already in simplest form. So the value of x, my hypotenuse, equals the square root of 709. Okay? And if you want to evaluate that even further, if you want to take the square root of 709, you get 26.62 as a decimal. And since that 26.26, I'll just go ahead and write it down here. This step below here is optional. You don't have to write it as a decimal since it's not a real world problem. But if you just want to do this to double check and make sure that the hypotenuse is longer than the two legs, then you're in good shape. So x is equal to 26.6, which is longer than the two legs, so you're all set there. Okay, so now we're going to do an example where we have to find the leg. Okay, so here we've been given our b equals to 9, and we are looking for a. Okay, and we've been given our hypotenuse c. Okay, so just like we did in the last example, we need to fill in the formula. So a squared, well, a is what we're looking for, and a is represented by my variable y, so I'm going to call it y squared plus 9 squared, because b is equal to 9, is equal to 21 squared. Okay, so just like the previous example, I'm plugging in the numbers. Okay, now simplify. So just like we do in normal with algebra, we have to isolate the variable. We have to get it on the side by itself. So what I'm going to do is I'm going to subtract a 9 squared from each side. Okay, so these 9 squareds cancel out, and I'm left with y squared is equal to 21 squared minus 9 squared. Okay, and then just like I did on the previous example, we're going to go ahead and evaluate, and I'm going to write that down here in step 3. So y squared is equal to whatever 21 squared minus 9 squared is. So 21 squared is 441 minus 9 squared, which is 81. And then 441 minus 81 gives me 360. Okay. Now, just like we did in the previous example, we're going to take the square root of both sides. Okay, so the square root of y squared is y equals to the square root of 360. So 360 is actually not in its simplest form. So I can actually break this radical down even further. I need to find a perfect square that goes into 360. Okay, so the first one I think about is 36, because 6 times 6 is 36. So I can actually break this down a little bit further into the square root of 36. And what times 36 gives me 360? 10 times the square root of 10. Okay, and so I know that the square root of 36 is 6, and this is multiplication in between these two. So my final answer will be y equals the square root of 36, well, that's 6, times the square root of 10. So there's no perfect square that goes into the square root of 10, so, okay. And that is how I write my final answer. And that is how you use Pythagorean theorem, and a little mini lesson on simplifying your radical.